All right, we're going to be going over the solutions to the first and second pages of your sketches. And so we'll look at those, and if you have a question, please raise your hand, hit the little raise hand symbol down at the bottom, or chat to me that you might have a question. Don't hesitate to chat the question, unmute and ask it, because it's very important that you understand kind of this portion, because when we go to AutoCAD, we're going to be doing the same thing, and you want to grasp these concepts. Okay? All right, let me put that down there. The first thing we're going to do is we're going to look at the solutions. I'm going to move this over here so it's off the screen. Okay. So the first thing, this one was kind of given to us, and I kind of drew it in paint and then just going over the sketches. Now we don't have dimensions or size notations or locations, so we're just counting the grid. And I'm going to go to each one, and I have it in a larger format. I know drawing in these tiny things was harder, but and especially for the dashes, you might only be able to get one or two dashes, or hard to get a center line for a gap. So let's talk about the line types again. The edges that we can physically touch are called visible lines, and they override everything else. The hidden lines are dashes, and they are physical edges, so they will stop at the material. You don't want these extending out, because they can start looking at like center lines, and center lines do extend beyond the material. Okay, so don't stop center lines at the edges. You want to continue those out, and that kind of discerns between these. So if we looked at this, we're looking at this edge right here, and let me turn on my highlighter. So we're looking at this edge right here, or behind this is the same edge. So it's this plane, and it just shows us that this is not solid. The next, let's say, so remember this is my primary view, or the misnomer front. So if I touch the top of this and I rotate that toward me, this is what I would be looking at, my finger pointed straight down here. So if you always want to come back to primary and then project around. All right, so we have our primary, we rotate up to what we call the top, and then these are the edges that we can touch. So we could have just projected this up. This, remember, we might have drawn a bounding box, and all your views will be shoved into the corners of that box. And that way we can project. These will be in alignment horizontally and these vertically here. So the width of the part is the same in this view and this view. Now if you went along this part right here, and you're looking at the top, but if you went down below the top and you kind of draw over, oh, I've got an edge right there, I've got a corner. So that's what this is. It's showing that this is not solid all the way through. So all these things we can touch. If there's anything underneath this plane down here, then we have to have hidden lines for it. So these are just planes or edges. Now if we look in the side, the top, it's going to be the same height. And if you wanted to use this miter line, like this, I could have drawn this one first or this one first and projected the geometry up and around, and that would be equidistant. That would be the same 1 unit offset here as it is here. So imagine just taking this part and turning it, rotating it 90 degrees, then we could have just projected left and right here. Let me see. So we can see this little castle block kind of thing right here. Comes down 1 unit and goes back up, and that's this plane right here. Over here we have this hidden edge, and that comes from the back side of this. So all this stuff right here I can touch, but once again, if there's anything over here, then that's a hidden edge that's projected right there. Did anyone have any problems with the first one? I'm going to move this over so I can see. All good. Thank you for the feedback there, because I need it. Here's number 2. For the first time, we have something circular, and it said on the first sheet, if you do not see the back plane, assume it goes all the way through. Also, assume that things are equidistant side to side, which means symmetrical, or like a mirror if it looks that way. So, this right here shows me that that is my primary view, whatever that arrow would hit. So we go ahead and draw that outline. And if we draw our visible lines first, then, you know, anything that we have, so I would draw all my visible lines in all 3 views. I've got this. If I had a box around here, this would be the same width. So that projects up and down. I can project this straight up, and that's how wide that would be, because I don't want to count that again. I don't want to measure it again. Go straight up again, and then these little blocks are this width. So you can see that when you line things up left and right, this way, top to bottom this way, in other words, these sitting on the same plane and then both in alignment on the left hand side, they'll be the same length. The only thing that I had to measure here was the width and then how wide these little blocks are. So if you see here, they're 1 unit. So we have these little cubes, these little castle blocks. And why do I have a line right here? It's because anytime we change from a vertical plane to what we call an incline plane or an angle, we're going to have a seam or an edge right there. Same thing right here, but this is the end of the part. Now, why do I have one right here? Because we've gone from an angle to a vertical plane right there. We're going to have that edge right there. Did you guys get that? So this edge is, yes, it's the top of the part, but this right here is an angled plane. And when you transition from an angled plane to a vertical plane right here, you're going to get that corner. So I could go ahead and project these over, project this over, like this. But we're still going to have these edges right here. So if you see something that you missed on this, go ahead and draw that into your drawing. I'm going to back off all these marks so that we can see it better. Now, this could be solid all the way through, unless we put these hidden edges right here. And they can connect, they will connect to the geometry because they are a physical plane or edge back behind there. So we're talking about this edge or corner or that corner. And they're on the same plane, so we just draw one. All right, one dashed line. So these are hidden lines. That's just dashed lines that are equidistant. All right, when we have all of our visible lines drawn, it's very easy to come back over, and I could take a ruler and I could start right here and say, yep, I've got that one, I've got this one, oh, I've got this right here. So sometimes running a ruler left to right and top to bottom, you can check your geometry to see that you have everything that's required. So we have this visible edge right here, but when we drag our ruler, let's say I looked at my ruler here, yep, I got that, yep. And then I've got this, drag that horizontal rule down, I've got that. Now, right here I have a hidden edge, but I also have a visible edge. So the visible line is going to overrule the hidden line there. We don't draw another hidden line like right down below it. I've seen people try and do that. That would be really confusing. So if I drag that horizontal rule down here, I see, oh, I've got a hidden edge back here. And that would allow me to just line up a horizontal rule or come over on this grid and draw a hidden line right there for this backside corner. Now holes have a top and a bottom. It's like the apex, the very northern apex and the very southern. If you measured all the way across there, from the side it could look like a square notch. But we're going to go ahead and start right on this northern quadrant of a circle. That's the north, south, east, and west. So I'm going to draw that across. I've got a hidden line here. And then I've got a hidden object right here. So dragging my ruler down, I've got a cut that starts right there. And then it stops down here. So I'll have hidden edges for that hole all the way through. And then let's look at the top. Same thing east to west. Alright, so if I had a ruler and now we're dragging it left to right. Same thing here. I'm going to have these two. Now once I get those and I've got my hidden lines drawn, the last thing on the totem pole, the lowest man, is our center lines. And I want to talk about these bullseyes again. It's like a target, right? It looks like a crosshair. It's going to have a plus in the middle. But you have to have the plus with a little space around it and then a leg that extends beyond the object, the circular object. So if this were only a semicircle, it would only have 3 legs because this part down here would not be circular. So as long as you have that curvature in that north, south, east, or west quadrant, because these are vertical and horizontal, you'll extend that out beyond that circular object. And we don't stop at that circle because that would look like maybe a hidden line or something to do with geometry. This is essentially where we're going to locate this hole to. From these center marks, we locate the hole. We don't do it from the geometry of a circle. Just like drilling on something, we have to find the center point, right? So now if we look at a cylinder, we have this cylinder here, we can have this bullseye in the front, but then what does that axis look like going down? It's a straight line, right? It goes all the way down, equidistant to all sides through the center. And that's what we have here. Notice that this is extended just a little bit. Now we're going to be able to set the length of extension when we get into AutoCAD. But you can, your lines may have been very short, you know, on that grid. So you can just have just one dash. That is enough, like from one side to the other. That is enough to show that it is a center line. This is not a dot. It's just the way this highlighter is drawing it. It's a dash. So a line, dash, I'm going to draw it here. A line, a dash, and a line. You don't have to have as many breaks as this line has. And that's something I might not have told you guys. And that can be a little confusing, and it's super hard to draw on a tiny piece of paper. Does anyone have any questions on this one? Okay, we're going to move on to the third one, then we're going to stop this video and we'll start another one. So we draw this overall shape. This is our primary right here. So we're looking at the hole. We see this shape. Thank you for the feedback. And we're going to draw that. So as if we drew this in 2D, we're going to push it back 4 units and make that 3D. So I can go ahead and draw this. I know it's the same length. I have to count how deep it is. And I'm going front, top, and right. You could go front, right, and then draw the top. Doesn't matter in that order. But I've got a corner right here where I have one angle going to another. So I'm going to draw a line up here. There's an edge. There's another edge at these 2 angles. So I draw that up there. And these lines, of course, would stop at the geometry. I'm just showing you how I would project it. Alright, that's all I can touch from the top. There is nothing else that I could touch. And so when I come back to primary and touch the right-hand side and rotate it around, what can I touch on the right-hand side? Well, my finger can go all the way across there and touch that because it's higher than this point. So we know the height of the part is the same. We have this point right here. We have the same bottom because it's the same part, and the thickness is the same. So if I drew the top view, I could just project this around and project this around here and get my width. So that miter line is super helpful, and it's really best, you know, if I have my visible edges, then I can project my hidden edges. So what I forgot in the front was this hole right here. I draw this one. I've got in the top, I'll be looking at the east and west quadrants, or the extents of the circle in the east and west per se, and then I would project this up. Now this stops right at the geometry. Do not let that extend. Then on the other side, that gives us the full width, which would be the full diameter. Same thing here, the full height, which is the same as a full diameter, because it's the same all the way around no matter what angle, if you go right through the center and measure anywhere around there. So we've got those. Now if I'm touching this side and I bring a ruler across here, okay, I've got that one. Is there anything that I cannot touch here? Cannot touch that edge through this side. So I have a hidden edge here. What about this one? Well, if you look, that one is directly in line, and you can see it on the grid with the quadrant of that, the top quadrant or the northern quadrant of that circle. So we just put one hidden line. You don't put two hidden lines. That gets really confusing for people. Clarity is the most important thing. So taking all this stuff off, once I have my hidden lines, I've got to say that this is not a square cut. This is not a square cut. So I've got my plus, and I've got 4 legs just drawn just outside the circle. Do not stop at the circle. Once again, you'll have a gap between your plus and your 4 legs extending beyond. So I could project this up. That's in the same place. And I could, once again, just have 1 dash. At the very minimum, you have 1 dash. Okay, if you can get more in there, that's great. To the side, we're going to do the same thing to show that this is not a square void or steps or something else like that. A protrusion, it could be a protrusion going out like this. That's why we put that center mark in there, to show that that is circular. We can see it here, but you can't tell it here. Does anyone have any questions on this one? Okay, we're going to stop this recording and we'll start the next one.